In this LeetCode problem, we have to merge two sorted linked lists. So we have the list 1 and list 2, and we need to merge those two linked lists into one sorted list. So basically we have the list, the first one 1, 2, 4, and the second list 1, 3, 4. Then we have to get 1, 1, 2, 3, 4, 4. So what is the linked list? The linked list has two parameters. One is the value and another one is the placeholder, where you have the indication whether you have the next node or not. If you have the last node, the next parameter that you see here will be none. In order to solve this problem, first of all, we would have to create a dummy node, and then we have to create a tail pointer. A tail pointer points to the current position in the new merged list. Let's take a walk through and see the solution step by step. As we already said, we have two lists. We have a dummy list and a pointer list, a tail list. First step, we have to compare those two nodes, the first node of the first list and the first node of the second list. The value is 1 in both lists. So we compare the value, and if the value of the first list is smaller or equal to the value of the second list, we assign the value of the first list to tail. So here we will have 1, and we jump to the next node in the first list. Then we also move to the next placeholder in the tail. Now we compare this value, the value of 2, with the second list still of the value of 1 from the first node. In this case, the value of 1 is smaller than the value of 2, which means that we place the smaller value to our tail, and we jump to the next node in the second list. Here we have to jump as well to the next placeholder. By the way, after each step, we will have a dummy linked list. All right, now we are going to compare 2 with 3. 2 is smaller than 3, which means that we place 2 to the tail, and we jump to the next node, and in the tail list we jump forward to the next placeholder. Now we are comparing 4 with 3. 3 is smaller, it goes to tail. Yeah, we forgot that after each step in the dummy list we have all sorted values, and so we jump again forward to the next node. Now we're comparing 4 with 4. It's equal, which means that 4 from the first list goes to tail, and we still jump to the next, and it will have none. Since it is none, we can finish the dummy list, but before we finish it, we want to append all nodes that are left. We still have one node from the second list. We just append it to tail, and now we get a full list of all values that are also sorted. Now let's go to the code, and basically in the LeetCode you have the same function. I copy pasted, and let's recreate the same but in Python. So we are comparing two values: the value on the first value from the first list and the first value from the second list. Before we are comparing it, we have to create a dummy node. The variable dummy has to point to the list node. So basically this is our list node. And we also need a tail list, which is also a list node, because it should point to our variable dummy. And we have to merge the two lists by comparing nodes. For this, we are saying while list 1 and list 2, which basically means while they are not empty, we compare if list 1 value is smaller or equals to list 2 value, then we want the tail next, which is our placeholder that I mentioned before, to be equal to list 1, and then list 1 should be equal to list 1 next. So we are basically jumping to the next node in the list 1. If this is not true, we want tail next to be list 2. So basically it means that the value from the second list is smaller, and that's why this value should be stored first. After this, after we are placing the value to the tail, we always have to jump forward. We have to go to the next node, like basically to the next placeholder. And once we are done, once one of the lists have the parameter next, if list 1 attach the remaining nodes, tail next equals to list 1, but if you have any nodes in the list 2, then tail next is equal to list 2. Of course, we have to return the merged list. Let's try to run it. So as you see, we have the same output: 1, 1, 2, 3, 4, 4. And let's check it again: 1, 1, 2, 3, 4, 4.